time when we will meet together. The next lecture will be given by Mariusz Janiak, my colleague, and it will concern the programming and utilization of MATLAB. So more or less you will repeat the same thing we have done with Mathematica during that period. So you will have to have the possibility to compare both systems and to find what are the similarities and what are the differences between them. Okay, I hope that you can hear me. Just please confirm.
Hello, yes, we can.
Okay, thank you very much for this confirmation. And today's lecture, this is a kind of summarization of everything what we have done, and actually it also will summarize this stuff which you will have with Mr. Janiak, and it is a kind of small introduction. So let me share the screen. So in a part, it will be the repetition of this, what we have talked about on the first or the second lecture before we started working with Mathematica. And I would like just to make sure that you understand clear what are the needs and what is the way of doing things by scientists and engineers. So this is what I will concentrate on. So we will summarize the part connected with the engineering, so working with the systems. We will summarize the part connected with the science, so let's say making experiments, and then just I will give some final conclusions. So you already know that scientific, this is something related to science. Everybody knows this in fact. So so the science, this is the knowledge about the natural world, and scientist, this is a person who is learned in science, and especially in natural science. This is what we should remember about. And engineering, this is something related to design, and this is just the application of science and mathematics in nature. So engineers try to change this nature, and the tools for them are these what are provided by scientists, and among them mathematicians. Mathematics has a special meaning here because it allows us to describe the reality in quite uniform form. So the engineer, this is a designer or builder of engines, the basic definition, but you know that this word means today much more. And we have the third component of our lecture name. This is programming, so simply something related to programs. Of course, related to computer programs in the sense we understand this. So this is the act of creating these computer programs, and programmer, this is a person who does it. That's all what can be said here. And what are the needs of scientists and engineers? What do they do during their everyday work? So considering scientists, they acquire knowledge, describe nature, and predict behaviors. So this is what they are concentrated on. And considering engineers, they invent machines, design machines, analyze machines, build machines, test machines, and also keep machines running. Actually, the last task is, I think, the most boring one. And unfortunately, if you will end up as engineers, then it is quite large probability that you will just keep machine running, because this is the place where quite a lot of engineers are needed. But let's hope that also you will make some other things with the engineering, especially you will invent or design something, because I think that this is the most interesting what engineer can do. And scientists and engineers do these tasks in a kind of a process cycle. So we can distinguish in this process cycle something what we can call the pre-processing. So this is the defining the model and environmental factors, what we will work with. Then we have analysis. So here is the phase where some understanding should appear, some verification of facts which know about the environment. And then we have the post-processing of results. So in one word, one can say that this is just visualization. You can visualize this in computer, but you can visualize this also in reality. So it means you can build the machine. And tasks connected with this cycle are just in general three: modeling, simulation, and visualization. So this is what we have to do to perform our task, being scientist or being an engineer. And when you look to the dictionary, you will find that by definition, actually, the engineering, this is the application of science and mathematics by which our properties of matter and the sources of energy in the nature are made useful to people. So this is quite important for us, that we will apply that what science provides, what mathematicians has done, to change the matter in such a way that they should hopefully be more useful to people. And you can find also more detailed definitions. So there is the definition which says that this is the creative application of scientific principles. So you have to think when you are applying these scientific principles, and you have to be what is called creative. And this you will use to design or develop structures, machines, apparatus, or manufacturing processes, or work utilizing them singly or in combination. So the word which I would like underscore here is that word creative. Just in a moment, a few words more about this. So this is this part which is connected with the creation. It is said that the engineering, this is the creative application of scientific principles to construct or operate the same as above with full cognizance of their design. So simply here appears this understanding. And finally, this is the ability to forecast the probabilities under specific operating conditions. So here we have this element which we have called analysis. So these three elements will be connected with making the engineering stuff. So it is quite important that it has to be done in such a way that it respects an intended function, economics of operation, safety to life and property. So there are a lot of other aspects connected with engineer job, apart from just preparing the tool according to his or her knowledge. So I have said that we would like to concentrate for a moment on this creativity, that you have to make something creatively. So let's start with some definitions of this word, because I think that nowadays the meaning of this word is somehow misunderstood, in the sense that you can learn creativity on a course, on 3-day course, for example, but I claim that you can't. Let's look closer to this, what the creativity is. So the simplest definition you can find in the Merriam-Webster dictionary, it simply says that creative, it means that this is imaginative, and that's all. You can find in Merriam-Webster dictionary the definition of creativity, that this is the ability to create, but creativity, it is also the ability to make new solutions. So this is quite important, that when you create something, it should be rather something new. But you can find also in some other places, like Great Internet Multimedia Encyclopedia, which is now not present in the internet, but for quite long time it was operating there. It simply said that creativity, this is the state of the body enhanced by the acid, exactly speaking, lysergic acid diethylamide. So for those who a little bit know about chemistry, is probably quite clear that this is nothing else but LSD. And in some sense, of course, you can think that people become creative in some specific way after using such elements which let's say amplify your perception of nature. But of course, you should treat this as a joke. But anyhow, it is quite important that you have to make this in some specific way, that the way which involve a kind of your emotional reaction. So there is no creativity if there is no emotion. So as I said, nowadays there are plenty of places which claim that you can learn creativity during a 3-day training, on 1 week training, or I don't know. But variety is such that no one can't learn creativity at all. Creative, it is an ability which you simply have, and you can try to work on it to make it larger, but this ability you cannot get by course. So this is something similar like with teaching music. So of course you can try to play piano, but if you will do this good or wrong, it depends on your abilities. If, for example, you can hear the music the right way to play it. So to think about this creativity, I would like to compare this with something which I have called here creativity. So you can see that I have extended the creativity with the interjection ach. So I also provide here additional definition of creativity, which I have found in the internet. Actually, there is such a short article concerning that topic, and Joseph O'Connor has said the creativity, this is the sex appeal of the intellect. So I recommend you to try to find this small article in the net just to read it. I think this is quite interesting. But returning to this interjection, so this is the this is the interjection which is used to express some delight, refill, regret, contempt, or also joy, surprise, fear, sadness. Summarizing, to express emotions and to express spontaneous reaction. So just remember, when you create something and you are creative, then some emotions can accompany to this state. If there is no emotion, if you don't feel joy, surprise, or sadness, then you won't be creative for sure. So this is my opinion about the creativity. And returning to the tasks which are assigned to the engineers, which engineers are doing. So this is the design of machines, construction, modification, analysis, and operation. Of course, not all engineers do all the stuff, all the tasks, but at least some of them. And what kind of background should engineer have to do the work? According to the definition, it has to know the sciences, this which he or she needs. He or she has to know the mathematics as a basic tool for rewriting stuff. Okay, one can say that you don't have to know the higher mathematics, but it's hard to imagine the engineer who doesn't know how to subtract or add numbers, for example, how to calculate in general. So at least arithmetics you must know. And also there are plenty other kind of knowledge you have to acquire when you want to be engineer. You have to know logic, economics, safety. You have to know how to collaborate, because most of the things nowadays are made in teams. So this is quite important that such knowledge is also acquired by you. And also what is not very often taken under consideration, especially this last element, you have to have experience, and you have to know how to use so-called tacit knowledge, because this is just something which we simply know, and until we don't use this, having this in mind, we can use it in a wrong way. Okay, so what is the methodology of work for engineers? Is the use of heuristic to cause the best change in a poorly understood situation within the available resources. So this is one of the better characterizing definition, what should be the methodology to do. So we try to do the best change in a poorly understood situation. Usually it is so that we don't understand what we are working on, and understanding is coming usually too late, as one say, in the sense that when we start to understand something, usually we have new questions and new problems which we again don't understand. So what is important in this methodology, when you look at it, is that first we try to understand the problem and to provide its specification. This is quite important, that this specification would be complete. Then we elaborate some solutions. Then we try to evaluate these solutions by tests, experiments, and then we try to choose one of them, this which we will work with. And on this stage, we also work with the constraints in the identification, understanding, and interpretation. It is always so that we are working under some set of constraints, and we have to realize what kind of constraints these are. Okay, what kind of tools engineers have to work? So first of all, they can do prototypes. So this is quite popular to after the design stage, to make the prototypes to see how well the designed tool machine works. Then, of course, we don't have to build everything as it is supposed to be in final version. We can make some scale models, or so we can perform some simulations, and this was what we were concentrated on. Then, of course, there can be some destructive and non-destructive tests. We can have some stress tests, some failed products which we obtain, and this is also the source of knowledge how to work and what is the performance of the thing we have constructed. Switching to science and asking about the tasks, we will start with some definitions, as we did for the engineering. So the shortest definition of science, this is just written in Merriam-Webster dictionary that this is the knowledge, and that's it. So this is the opposition to ignorance or misunderstanding. And we have also a longer definition that this is a system of knowledge covering general truths or the operation of general laws, especially as obtained and tested through scientific method. So everything what we have gathered using the so-called scientific method, this is supposed to be a knowledge. And what is the task to scientists is just to organize this knowledge, because there are plenty of different things we know, but we don't join them together in the sense that should be. So we have to analyze the knowledge, we have to explain what we know, we have to do some prediction which allows us to make the next step. So as you have seen, for engineers, we have here the design, construction, modification, analysis, and operation. So the tasks are almost all different than for scientists. What is the background for scientists? Of course, sciences. So first, if you would like to become a scientist, you have to be trained in sciences, and then you can try to make new discoveries or give new theorems and such things. Of course, as a tool for scientists, there is mathematics, and almost all of them work in that way, even if this is the experimental science. So you also will need the mathematics to work at least statistically on this data you are working with. And then, of course, a kind of modeling. Very often this is just mathematical modeling, because now this is very popular tool to model things using the mathematics as a tool. But also here we can add that scientists has to be trained in logic, economics, safety, collaboration. Again, almost all work in science is done today, nowadays in teams. So you have to know how to collaborate for sure. And also here, quite important is to have some experience and to use properly this tacit knowledge. As you remember, for engineers, we have actually something very similar. So the background for scientists and for engineers is very similar. And this is why you can study here and think that after these studies, you become an engineer or maybe a scientist. So it is still possible to do both to go both the roads. Okay, what is the methodology when you are a scientist you should use? So we can refer again to the dictionary, Merriam-Webster, the dictionary, which says that these are principles and procedures for the systematic pursuit of knowledge involving the recognition and formulation of a problem, the collection of data through observation and experiment, and the formulation and testing of hypotheses. Of course, after this, when you have formulated this hypothesis, you have to prove it somehow. Then it become a real knowledge which other people will try, maybe, hopefully, will try to use. So again, when you look what kind of activity is required here, so you have problem understanding and specification, exactly like we have previously, observation, experimentation, then hypothesis formulation, and finally this proving I was saying about. So in both cases, you have to understand problems and you have to specify them. This is quite important because very often, after short analysis of a problem, we try to work on on the problem, but with no specification of it. And after some time, it can happen that actually we don't know what we are working on because new problems arises, new ideas arises, and finally we lose the point we were working on. So just remember to specify things which you should prepare. Okay, what kind of tools do we have being a scientist? So of course, this is the observation. So the most basic and the primary methodology used by scientists for ages. Then we have this modeling, simulation, and experiments. Some people say that simulation, this is also a kind of experiments, but simply not in reality. And of course, again, this mathematics, this is the essential tool to the sciences, I claim, I think. And when you look what was for engineers, we have here a little bit different set of tools. We have these prototypes, models, simulations, what is in common, and plenty types of tests. So in general, when you look at the work of the engineer who is designing something, nowadays he is mainly doing tests. Okay, so what should scientists and engineers do to summarize this for both kind of specialists can be answered in one word. First of all, they should think. So this is quite important that you consider stuff you are working on and you think about this, what you are working. And of course, they should experiment. So this is quite important. Experimenting build our curiosity and allows us to go step further when comparing to the place we are at the moment. And if somebody is asking why to think, so I can give very short and simple answer because it doesn't hurt. Maybe this is enough. If you don't have this curiosity and you don't want to think about this, what is surrounding you, so maybe you shouldn't be here at the university. And if you ask why to experiment, I can answer that experiments answer questions. So this is the basic duty which should engineers and should scientists do, just to answer questions. And if we look what kind of questions do scientists ask, we can say that they simply are asking why it is so, why something is happening, why it works. And when you look at what questions do engineers ask, then this question is how. How should I make it? How to do it to make it work? Okay, so to summarize all this, what I was going to say today, just I will recall the thought of Fyodor von Karman, who said that scientists study the world as it is and engineers create the world that has never been. So let's hope that you be the engineers who will create this world in such a way, or a scientist who will try to understand this what surrounds us. Okay, so this is more or less everything what I wanted to say to you. If you have any questions, if there are some elements of Mathematica I should explain to you in more detail, then we have still time to do this. So please ask the questions. Okay, so if you don't have questions, then we can finish now. That's nice. thank you very much for being here, and we meet on laboratory once more, and then you will work with Mariusz Janiak.
Excuse me, I've got a question, but when everybody leaves.
Okay.
I wanted to ask you to check email also.
Yeah, I have checked this, but unfortunately I haven't had time to answer to your email, so I will do this for sure.
Okay, thanks. Goodbye.
Goodbye.
Thank you. Goodbye.
So, okay, Jakub, so maybe instead of waiting until everybody will leave, because I'm not quite sure if it will happen, because usually some people stay in the sense that they are present. So maybe we will switch to
Breakout room.
So I will try to make one.